So it's a very good question. We are given that there are two metallic plates. One plate has charge sigma A, the other plate has charge minus 2 sigma A, and there is an external applied electric field of intensity E. These are the given informations for us, and these are metallic plates. Now we are asked to find out the charge on each surface. There are four surfaces. One surface is here, one surface is here, one is here, one is here. There are four surfaces, and we have to find out the charge on each surface. Now the similar example has already been given in the booklet. There is one important concept which we will use in solving this question, and that concept has already been explained in the example number 112, that is on page number 83 of this booklet. So referring to that, using that, we will solve this question very easily. And the concept is that the charge on the opposite faces of these two plates, charge on this face and charge on this face, these two faces will have charge of same magnitude and opposite sign. So I have assumed accordingly x and minus x. It's a very important result, and the students must remember this result, because it will be used whenever you have to find out the charges on the surfaces of the sheet. So it's very, very important result, and its proof is given here. Now, since it is x, this must be sigma A minus x, so that total of these two charges becomes equal to sigma A. It is minus x, so charge on this surface will be x minus 2 sigma A, so that the total of these two becomes equal to this charge. Now we have only one unknown, and that is x. If x is known, all these four charges will be known to us. Now how to find out this x? To find out this x, we are again going to use one more result, and that is E resultant inside metal is 0. This is a very important concept that you know, it is already there in the theory part of this booklet. So we will use this result to find out this value of x. Now how to execute it? Let us take some thickness of this plate and take a point in this plate. At this point, resultant electric field must be 0. Now at this point there will be 5 electric fields. These four charges will produce some electric field, and there is already E we have applied. So there are 5 electric fields at this point. Now out of these 5, 2 will become 0. How? This x will produce electric field at this point towards right. This minus x will produce electric field at this point towards left. So these two are producing electric field in left and right directions, and they have the same magnitude, so the resultant is going to be 0. Now the left parts are only these two charges and this E. So let us write the electric field at this point. Now if we have some charge and you don't know about its sign, the whole charge should be treated as a positive charge, and write down the electric field accordingly. So due to this, electric field at this point will be towards right, having value sigma A minus x divided by 2A epsilon 0. This whole charge will produce electric field at this point towards left, having value x minus 2 sigma A divided by 2A epsilon 0, and we already have electric field E here. Now to make the electric field at this point 0, what should be there? E plus sigma A minus x divided by 2A epsilon 0 must be equal to x minus 2 sigma A divided by 2A epsilon 0. Solving this equation, we will get the value of x. That will be the answer of x, but we have one more method of solving this question. This is method 1. Now another method I will give you, and that is a sort of very innovative method, creative method, which somebody can think. So from this you can get value of x, that will be your answer. Now let us come to the second method. For the second method, what I am doing is, we have these two plates. and they have charges sigma A and minus 2 sigma A. Now this E electric field we have applied externally. How this electric field is applied? We have to put some source of charge that will produce this electric field. Since this electric field is a uniform electric field, so the source of this charge will definitely be a plate. There will be large plate of charge which will produce this electric field. That plate can be on this side or this can be on that side. If it is on that side, it will have negative charge. If it is on this side, it should have positive charge. So I am assuming a plate having charge Q. This plate produces electric field E. So this E has been produced by Q. So equivalently I can say that there is no E, but there is a charge Q. This Q should be such that Q by 2A epsilon 0 must be equal to E, means Q must be equal to 2A epsilon 0 E. So we can equivalently replace this E by a plate of charge Q. Now you will see that how simply this question is going to be solved. Let us assume that this is X, this is minus X, this is X minus 2 sigma A, this is sigma A minus X. On this side is the opposite of this will be there, X minus sigma A, and on this side charge will be Q minus X plus sigma A. So that total of these two is equal to Q, total of these two is equal to sigma A, total of these two is equal to minus 2 sigma A. Now we have one unknown, that is X. In finding the value of X, we are again going to use the concept that resultant electric field in the metallic plate should be 0, and for that you take any point inside metallic plate. If you take a point inside this plate, then electric field at this point should be 0. For that this charge and this charge must be equal, because these and these are equal and opposite, so they will produce electric field here 0. They are equal and opposite, they will produce electric field 0. So what is remaining? Remaining is this charge and this charge. If these two charges are equal exactly, then electric field at this point will be 0. So to get the value of X, what you have to do is Q minus X plus sigma A is equal to X minus 2 sigma A. That will be the answer. The value of Q can be obtained from there. By solving this, you can get the value of X, and that will be your answer.